Let's continue with differential equations. So last time we discussed about what differential equations are, what are different types of differential equations, and how do we solve a variable separable differential equation. Now have a look at this example. If you have an equation like this, x y prime plus 4x squared plus y squared is equal to 0. Out here, if you see, it is like x and y, they are in such a combination, like it's more of implicit than explicit, so it is difficult to separate x and y. So in this case, it's difficult to use variable separable directly. So if you write given equation as 4x squared plus y squared over xy, that is y prime. If you bring y this side, this y is a problem, and if you bring this y on the left again, so it is not easy to separate x and y. So what do? We use a different method to solve such equations. Let's check what is the degree of numerator here, 2. What is the degree of denominator? 1 and 1, 2. So such equations when degree of numerator and denominator is same, these equations are called homogeneous differential equations. So this is an example of a homogeneous differential equations. How do we solve homogeneous differential equations? It's very easy. Number one, identify if your equation is a homogeneous differential equation. So steps to solve a homogeneous differential equation: we introduce a new variable v in the equation such that v is equal to y upon x or y is equal to vx. Second is we rewrite this equation in terms of x and v. Now remember, you have y prime, that is first derivative of y. So you need to differentiate this also. When you differentiate, remember v and x both are variables. So we have to use product rule here. So, and implicit differentiations, it becomes v plus x dv by dx. Replace y prime or dy by dx by this, and wherever you see y, write it as y vx. So just rewrite. When you do this, believe me or not, your equation will become variable separable. So once it has become variable separable, you know what to do. So let's start it with the help of an example. So here is a question. Solve x, y prime plus 4x squared plus y squared is equal to 0. So first thing is check. Is it a variable separable? It doesn't look a variable separable. Is it a homogeneous? So for homogeneous, you may arrange as numerator over denominator, or you can also see if the degree of each term is same. Out here xy degree 2, 4x squared degree 2, y squared degree 2, it is a homogeneous equation. So what do we do here? Given equation, we are writing like this: degree of numerator 2, denominator 2. So it is a homogeneous equation. So put y is equal to vx. When you put y is equal to vx, dy by dx will be v plus x times, we are using product rule, v as it is derivative of x plus x as it is derivative of v. Now we replace, or say rewrite, this given equation in terms of x and v. So when we rewrite y prime plus 4x squared plus y squared is 0, this is how it looks. And when you simplify it, after 2 steps, it looks like this. Now you can see your right hand side has only v and left hand side has x dv upon dx. So if you take dx and x to the right side, bring it down here, this equation will look like v over 4 plus 2v squared dv is equal to negative dx. It is a variable separable equation. Integrate and get your answer. Now again and again, over and over, I've been saying integration is really important. So make sure that you practice, revisit integration if you're finding it difficult to integrate after this step. So let's integrate this. So once you integrate, what do you get? Integrating this, we get v over 4 plus 2v squared dv is equal to negative dx over x. So obviously I can see we'll be using integration by substitution, and this is direct ln x. So when we integrate it with substitution method, we get this thing. Now you know, whenever we integrate, we put plus c. If each of your terms in your answer has log, then if c is a constant, its log is also constant. So instead of using c, you may use ln c, so that when we have ln everywhere, we can compare terms and get rid of ln. So I can write it, this will be negative ln x plus ln c. So you can merge it to ln c upon x. So 1 upon 4 ln 4 plus 2v squared is this. When 4 is taken to the right hand side, it gives you c squared over x squared. Ln's are gone. So you're left with 4 plus 2v squared is equal to ln c4 over x4. Now, v is something that we introduced. So we have to replace it by its value in terms of x and y. So you get 4 plus 2y squared over x squared is equal to c squared over x squared. So I think it's a good form. I like this, but you can still simplify it to 4x4 plus 2x squared y squared is equal to, it should be c4, but a constant raised to the power of 4 is another constant. So you can write it as capital C. So this is the solution of the differential equation, and since it has plus c, so it is a general solution and it represents family of lines. So this is how we solve simultaneous differential equations. So how do we do? Number one, identify if your equation is a simultaneous differential equation. Second, introduce a new variable v, so that v is equal to y over x. Replace y by v, and then simplify. Your equation will become variable separable. Solve it, go back and replace v by its y value, and that's your answer. So that's all here. And this gentleman, Bernoulli, was the first person who came up with this idea of homogeneous equation. We should always appreciate efforts of anyone who has contributed to any theory or who has touched your life in any possible form. We should be thankful. Thank you. So that's all in homogeneous differential equations. If you like this video, please consider subscribing it, like it, and share it. And don't forget to press the bell icon so that you're the first to receive a notification when a new video is posted. You can also reach me at jalajmaths@gmail.com or jalajmaths at Instagram. And till we meet again, take good care.